So today, i-consider natin yung discontinuities na makikita natin sa floor function or the greatest integer function. So let's take a look at f of x is equal to the floor of x. Ganito yung graph niya. By inspection, we could see na meron tayong discontinuities whenever x is an integer. So in particular, let's take a look at x equals 2. We could see that there is a discontinuity at x equals 2 because this is a step function. This is a jump discontinuity. Ang gusto nating tignan ngayon ay ano ba yung limit ng f of x as x approaches 2 if you're approaching 2 from the left. So papaganito yung direction natin, papunta kay 2. If we take a look at our function, yung behavior niya, so as we approach 2 from the left, we are approaching this point. And that point has this y value of 1. So we could say that the limit of the floor function as x approaches 2 from the left is equal to 1. Pwede rin natin siyang i-analyze, no? Like, kukuha tayo ng numbers to the left of 2. So, mga 1.9, 1.99. Pag finlore natin yon, it still goes down to 1. If we evaluate naman the limit of f of x as x approaches 2 from the right side, so papaganito, we are considering values that are approaching 2 pero mas malaki sa 2. So, mga 2.01, 2.001. And visually, can see na habang lumalapit tayo sa 2, yung graph natin, yung points ng graph na nag-a-approach sa x equals 2 ay nandito sa taas. Lumalapit siya dito sa point na ito, itong point na to. And the y-coordinate of that point is 2. So tama naman, no? If you consider points that are greater than 2 but are close to 2, like 2.01, 2.001, magfo-floor siya pababa kay 2. So the limit as x approaches 2 from the right side of the floor function is 2. If we actually evaluate the floor function of x at x equals 2, then the floor of 2 is, of course, 2. Ano? Now, let's zoom in to the graph of our function at ano ba yung gusto nating makita. As we approach 2 from the left, no, itong section na to nung graph natin, the one that I'm highlighting in red, well, mula sa point na to, it is continuous, right? Kasi it's just a constant, it's a constant value. Pero hanggang saan mag-stop yung continuity niya? Ano bali yung parang edge? Well, we can't really speak of an edge na hanggang dito lang yung continuity. But for all these values of x, continuous yung function natin until ma-hit natin yung x equals 2. In a way, continuous tayo hanggang sa 2, pero hindi kasama yung 2. Now, if you take a look naman dito sa right side, continuous tong part na to. Pero kasama si 2 dun sa points na yon. Basically, your discontinuity starts after 2. Dito, yung continuity mo, it continues until, well, hindi siya aabot ng 2. Pagdating niya ng 2, magiging discontinuous na siya. Pero dito sa taas, yung continuity nitong line segment na to, aabot siya hanggang kay 2. So based on that, let's form the following definition na given a function f is continuous from the right at point A. So ang case natin ditong tinitignan, no, yung 2 and continuity from the right. Continuous siya from the right, like itong case na to, if, ano yung rule natin sa continuity? The limit is the same as pag in-evaluate natin yung function doon. But now, since we're only looking from the right, we'll only evaluate the limit from the right. So, x approaches a from the right of f of x pag equal siya dun sa function evaluated at a. So, in our case, dito sa figure natin, the step function, the floor function, is continuous from the right at x equals 2. Kasi yung limit from the right as x approaches 2 is equal to 2, which is equal to the value of the floor function pag in-evaluate natin siya at x equals 2. So, equal yung value ng function at a dun sa limit of the function as x approaches a from the right side. Pag nangyari yun, then f is continuous from the right. Building on that same definition, we can talk about continuity from the left. Of course, in our example, hindi na siya continuous from the left. But we could say that f is continuous from the left at point A if we take the left-hand side limit of f of x as x approaches a, and pag kinumpare natin siya sa value ng function at x equals a and evaluate natin siya equal, then may continuity tayo from the left side. Let's now define continuity on an interval. Before, ang continuity natin, nakatingin tayo sa isang point. Now, let's look at the continuity at an interval. So, we say that a function f is continuous on an entire interval if it is continuous at every number in that interval. Let's do a quick example. We're taking a look at the function f of x is equal to 1 plus the square root of 4 minus x squared. We want to verify that this is in fact continuous on the interval, on the closed interval, negative 2 to 2 inclusive. So anong alam natin? We have a squared function. Bawal maging negative yung yung values sa loob ng square root. Otherwise, magiging undefined siya. Wala na tayong values sa real. So let us first consider values of a that are in the interval negative 2 to 2 pero hindi muna natin isasama yung boundaries. Kasi sa boundaries natin, pag lumampas siya ng 2 at ng negative 2, wala na yung function. Meron na tayong discontinuity. Tignan muna natin yung negative 2 hanggang 2. So to determine continuity, we evaluate the limit of f of x as x approaches a. And that is just the limit as x approaches a of the quantity 1 plus the square root of 4 minus x squared. Using the properties of limits, this would be equal to the limit of 1 as x approaches a. 1 lang yun. Plus the limit of the square root of 4 minus x squared as x approaches a. And we get 1 plus the square root of the limit as x approaches a of 4 minus x squared. But 4 minus x squared is a continuous function. Polynomial siya. So this is just equal to 1 plus the square root of 4 minus a squared. But 1 plus the square root of 4 minus a squared is precisely f of a na nakita natin na equal dito. So we could say that in this open interval, our function is continuous. Okay na, continuous siya dun sa loob. How about sa boundaries? So we consider the boundaries x is negative 2 and x is equal to 2. So for the leftmost na boundary, dahil hindi na defined yung function to the left of negative 2, let's consider values na nasa right ng negative 2. Now, the limit of our function as we approach negative 2 from the right side will be, well, substitute muna natin kung magkakaproblema. But if we do this, it's just 1 plus the square root of 4 minus the quantity negative 2 squared, which is equal to 1 plus the square root of 4 minus 4, or this is just equal to 1. The limit exists and it is equal to the value of the function pag in-evaluate sa kanya. So, continuous tayo from the right, dito sa x equals negative 2. Similarly, if we evaluate the limit of our function as x approaches 2, positive 2, from the left, this will just be 1 plus square root of 4 minus 2 squared, or 1 plus square root of 4 minus 4, or 1 din. We have shown na continuous yung function from negative 2 to 2 na hindi kasama yung endpoints, and we have shown na continuous din siya from the endpoints. So, since sa left endpoint, it's continuous from the right right endpoint is continuous from the left. So, the entire thing, from negative 2 to 2, including the boundaries, the function is continuous doon sa interval na yan. Okay, now, let's take a look at composite functions. Let's say we have a function f that is continuous at b, and we have a second function g of x, such that when we evaluate the limit as x approaches a, pupunta tayong b. Then, the limit of the composite function f of g of x as x approaches a, so si x lumalapit kay a, si g lalapit siya ngayon kay b. And since continuous si f kay b, this will just be equal kay f of b, but b is the limit of g of x as x approaches a. So, this is equivalent to f of the limit of g of x as x approaches a. Ano yung implication nitong theorem na to? It means that the limit symbol, ito, and the function symbol, ito, ay pwedeng magpalit ng position. Like so. If the function is continuous and if the limit exists. So, ano yung implication niya sa continuity? O, pasok na natin yung continuity. If g is continuous at a and f is continuous dun sa kung ano man yung value ng g at a, na meron kasi continuous siya kay a then the composite function f of g, which is the same as f of g of x, is also continuous kay a. So, continuous function, nasa loob ng isa pang continuous function, ay continuous pa rin. Okay. So, a couple of examples. Where are the following functions continuous? Let's take a look muna kay A. We know that 3x squared is a continuous function, y equals 3x squared, kasi polynomial siya. Then, cosine is also a continuous function, cosine of x. So, we have a composite function of 3x squared, polynomial, continuous, being evaluated inside another continuous function, cosine. So continuous inside the continuous function. Then we could say that h of x is continuous everywhere. Kasi 3x squared and cosine are both continuous everywhere. Next, capital F is equal to 1 over the square root of x squared plus 7 minus 4. Start tayo with x squared. That is continuous throughout its domain. X squared plus 7, nagdagdag tayo ng 7. That's still continuous throughout its domain. Yung square root, alam natin na hindi na siya defined, no? Pag magne-negative yung values sa loob. But, let's take a look at it. X squared plus 7. X squared, ang lowest possible value niya, 0. Nag-add pa tayo ng 7. So, itong x squared plus 7, this cannot be negative. So, itong square root of x squared plus 7, then this must also be continuous everywhere. Then, nag-minus tayo ng 4. So, you have a function that is continuous everywhere, minus 4, which is also continuous everywhere. Then, this entire denominator, it's also continuous everywhere. Now, if you take a look at the numerator, kung ito lang yung consider nating function, y equals 1, it's also continuous everywhere. So, remember, if you have a continuous function over another continuous function, then the resulting function must be continuous throughout its domain. So, titignan na natin ngayon yung domain niya kasi continuous siya in the domain eh. Ano ba domain nito? Well, yung denominator natin, bawal pa rin siyang mag-0. So, any x values na magpapa-0 sa denominator, hindi defined yung function natin doon. So, the denominator, so let's look for the values of x na magiging 0 yung denominator by equating the whole denominator sa 0. We'll get that the square root of x squared plus 7 equals 4. We could square both sides to get x squared plus 7 equals 16. This will give us x squared equals 9 or x is equal to plus or minus 3. So, capital F of x must be continuous throughout the set of real numbers except at x equals 3 and x equals negative 3. Writing this down, in the interval notation, we could say that capital F is continuous from negative infinity to negative 3, then again at negative 3 to positive 3, and then again at positive 3 to positive infinity. So, continuous siya throughout these intervals.